Good afternoon and welcome to the Red Couch live here at Electronica in Munich. My name is Michael Brunn, I'm the editor-in-chief of E&E magazine. During the whole trade show we will talk with important people from the electronics industry about topics that are moving the industry right now. And you can watch us live here at the trade show or via YouTube or our Facebook channel. And right now I would like to welcome Dr. Joachim Schlosser, Manager Application Engineering MathWorks, and we will talk about simulation and verification in the smart grid. Welcome, Joachim.
Thanks.
Get first applause.
Yeah,
perfect.
great.
Thank you very much. Okay, let's start with the questions. So, what are, from your point of view, the main challenges in the smart grid?
Well, from my point of view, it would be too easy to just consider smart grids and especially energy revolution as a political problem and as a political challenge. Although for some infrastructural changes, of course, the political decision making is important and is very necessary. But in the end, the energy revolution really, it begins and ends with the developers of the individual device, of the individual energy production device, and of the individual consumer device, as well as the machinery that's out there. And it begins and ends in the minds of the engineers that develop those devices. Mm-hmm. So, of course, the challenge is not only to distribute the energy accordingly, to weigh off the producers of energy and the consumers of energy, but also to decrease the level of energy consumption at all, which means that the developers increasingly have to deal with requirements to design to power consumption and design to power efficiency. To me, this is maybe an even bigger challenge because it affects not only the devices attached to the grid, but basically it impacts all devices that consume power at all.
So, and why now is simulation something you are dealing with of any importance for the smart grid? What can it bring for the engineer? How can it help them?
Well, energy producers and the manufacturers of energy producing devices and machines, they need to verify that the machines that they create actually, that those do not disturb the grid. Mm-hmm. You know what happens if you attach, for example, a wind turbine in an unsynchronized way to the power grid? You get a big power outage, and with various nice effects that can occur as part of that. So it's absolutely necessary to verify the robustness and correctness of that machine when it comes to synchronizing with the power grid. This is on the producing side. On the consumer side, of course, all those devices need to be able in future to deal with minor power outages, with a decreasing level of quality in the power grid. And on the third hand, all developers of devices, maybe consumer devices, they need, as I said, to design towards reduced power consumption. So simulation is essential because you can do it without attaching your device to the real world. You can do it in a controlled environment. You can induce for example, power outages, small power inconsistencies, and check how your algorithm, how your system will behave to that. You can simulate a part or even a larger part of the grid and see what happens if you attach your wind turbine, your photovoltaics to this grid. What happens? Will it work correctly without harming a real-world grid?
If you get a little bit more specific, what can be simulated, or the other way around, is there anything that cannot be simulated regarding the smart grid?
Rather than telling you what can be simulated, I would like to tell you what actually is simulated, what companies out there do with our tools. So for example, grid stability. scenarios, including power outage scenarios. And it's a lot cheaper to do this in simulation than in the real world.
I think so, yeah.
And of course the effect of power inverters on the grid as well as on the devices. Power producing machines or energy producing machines together with their control algorithms, including environmental conditions like maybe weather or whatsoever. For wind turbines, it might be the wind speed, turbulences, all those effects can be simulated. Then, of course, for power-consuming devices, all aspects of the mechatronics, be it hydraulics, electronics, mechanics, everything. Fujitsu, for example, they implemented a power shaping for their tower-mounted wireless transmission units to save energy and shape the power that this device consumes according to the amplification modification. Another user organization, for example, they took their hydraulic press that they produced for over 30 years and created a simulation of that. And then they found out that they could actually save 75% of the consumed energy just by a little bit of downsizing while maintaining the performance and by better control algorithms. And if you think, well, the machine runs, it has been produced for 30 years, but still there's so much energy efficiency lying and standing around in Germany's and Europe's production halls, which might be leveraged using simulation.
So how can Simulink and MATLAB, the products your company is making, especially be useful for the development of the smart grids?
Yeah. So if we draw the link from the previous answer to the algorithm side, most devices need controls and logic, either for their core functionality or, as in the Fujitsu example, for controlling their power consumption at all. Designing and especially optimizing this kind of systems, that's what made MATLAB and Simulink popular and great. And if we move a little bit forward in the topic, we also see increased usage of our tools in designing systems of systems. If you think of a smart grid, it's basically a system of systems. You have many different systems, but not all of those systems, or the minor part of that systems, is under your control. And everything else is environment to your system. And taking this environment into consideration by modeling and simulating it, this is something where MATLAB and Simulink are heavily used, and we see a huge push toward that.
Another aspect of your software is validation and verification.
Yeah.
And how can that be useful?
Well, you better not do trial and error with a grid, as said before. So you better come up with a really functioning algorithm, and you better not do trial and error with expensive machinery, and you better not do trial and error with mass-produced devices. If you ship them, you better verify robustness before that, and even more, you better verify robustness and correct behavior before producing them. So in the development phase, using simulation and virtual testing to validate and verify the algorithms, this is at the core of MATLAB and Simulink. And if you think of devices or portions of your system that you do not want to model in MATLAB or Simulink, usually you still have some kind of C code, or you produce some kind of C code, which of course then should be formally verified, maybe using the polyspace code verification.
Okay. So there are a lot of different players in the energy industry, and who should use your software with what purpose?
Yeah. So again, rather than answering to what kind of organizations should use, I would really to go back and say what companies are using, or what kind of organizations are already using our tools. So let's start with organizations developing power producing or energy producing machines, such as photovoltaics companies, wind energy manufacturers, water, but still, of course, fossil energy burning devices, both in small scale and large scale. As said, they design a machine, they create and design a big device, and you better not only take care of the algorithm, but that the algorithm matches the electrical architecture, that it well interacts with the whole rest of the mechatronics, the mechanics, that the blades act accordingly. Think of a wind turbine. When strong winds come in, you have to turn the blades accordingly, you have to turn the yaw accordingly, and you have to control the power inverter accordingly to give enough stability, power efficiency, and reduce maintenance cost. If you go to the grid providers, they use our software for pricing models as well as robustness and stability considerations. And then, of course, all those machines consuming electrical energy, either the large scale, really heavy industry machines, but also the smart things like phones and ECUs in the cars.
Mm-hmm. Okay, in Germany there is this big discussion about the energy revolution. So let's get it on a little bit more bigger area. What kind of impact will this transition, this revolution, have for engineering in Germany?
So I think basically we're very well equipped in Germany. We have a fairly working education system. However, there are some discussions, but I say it works. We have great engineers. We have great talents. It's just, as I said, the energy revolution. This is not purely a political challenge where we say, oh, politics have to draw some decisions and do something. It really starts with each and every engineer. So from my point of view, every engineer working in an organization that develops something should be aware that what he or she does has not only an impact on the revenue of his or her employer, but due to the fact that the machine either consumes or produces energy, it has an effect on society. And if every engineer is aware of that and has in mind the design to energy efficiency, I think we will come a good way along. Of course, we need some coordination beyond that, and of course we need some coordination of the different devices. But as said, simulation is one means to actually reach that stage where we not only talk about interaction of systems and not only hope that what we develop will be useful, but where developing organizations can cooperate and actually verify that their different development projects can cooperate in a nice way by simulating before they even put the first heavy steel plate in place.
Okay, I see we're running out of time. Final question, short answer. What are your personal opinions about the smart grid? How will it develop within the next 5 to 10 years? Short answer.
Short answer. So I hope that Germany and Europe will play a big role in this development, because we have both the political situation that wants this energy revolution, and we have the bright heads in Europe that could make it happen. So I'm on a very positive side, and also the signs that I get from our user base, and believe me, there is a user base of substantial size that can give us some input on that. So I'm very positive about it, and I think we as a society, we can make it.
Okay. Thank you very much. Ladies and gentlemen, that was the Red Talk Couch about simulation verification in the smart grid, live from the Electronica trade show. I would like to thank Dr. Joachim Schlosser from MathWorks for giving us some insight on this topic. And thank you very much for watching and listening. We wish you all a successful trade show. And if you are interested, you will find this interview and all the other interviews we are doing during this trade show later on at the Publish Industry YouTube channel. Thank you very much.